This is CSaP's Science and Policy Podcast from the University of Cambridge, where we're bringing you the latest evidence and expertise to improve public policymaking.
What impacts are people having on remote environments? Advances in technology and engineering have given us the ability to extract minerals deep from the seabed, fish in the freezing waters around Antarctica, and put thousands of satellites into orbit. As the human exploitation of these spaces increases, so too do the negative consequences of pollution, habitat loss, and other forms of environmental degradation. The tourism industry in the Antarctic is expanding, with over 50,000 guests visiting in 2018. There are now 70 research stations, with international scientists regularly travelling to and from the continent. What impacts do the regular exchange of people and equipment have on native wildlife and ecosystems? What invasive species are introduced by drilling deep into ancient Antarctic lakes? And how should we balance the pursuit of scientific understanding with the possible consequences of our disturbing a pristine environment? There are currently countless man-made objects in orbit, ranging from microscopic fragments of metal and paint to satellites the size of buses. Every year we send increasing numbers of communication and observation satellites into the near-Earth space environment, and much of our lives on Earth now depends on a functional space-based infrastructure. With orbital bodies travelling at kilometres per second, even tiny debris has the potential to cause catastrophic damage in a collision. Is disaster inevitable? What potential solutions are there for reducing the likelihood of collisions? And how can the increasingly privatised space sector cooperate to ensure precautionary behaviour? We can now prospect for and mine metal and mineral deposits from the deep seabed. What unintended consequences could doing so have on the marine environment? How can deep-sea mining be regulated? And is it even financially viable? There are also questions of sovereignty, cultural heritage, and accountability. It is crucial that all stakeholders are represented in these discussions and that exploitative historical legacies are challenged. Within this podcast episode, we will consider these questions and more through the lenses of science and policy. We'll aim to determine the most pressing near-term and future challenges regarding exploitation and degradation of the deep ocean, Antarctic, and space environments.
Hi, I'm Rob Doubleday, host of CSaP's Science and Policy Podcast. You've just heard from PhD student and CSaP policy intern Anthony Lindley. In this week's episode of our series on deep ocean, space and Antarctica, we're exploring the risks and policy questions posed by ways humans are interacting with and exploiting these environments. Throughout this episode, we'll be exploring the risks and questions involved in deep sea mining and how scientists are managing the delicate balance between studying and protecting fragile Antarctic environments, and also the growing problem of space debris. Today we're joined by political geographer Dr John Childs from the University of Lancaster, Dr Kevin Hughes, who's an environmental scientist at the British Antarctic Survey, and technology policy researcher Dr Nikita Chiu, who's a specialist in robotic and outer space governance. Turning first to you, John, could you tell us a bit about the current state of deep sea mining?
First thing to say probably is that the fact that oceans and ocean space in general have become an object of political inquiry, that's a fairly recent thing. I mean, there's been a long history of oceans being marginalised from political thought. You know, there's been a tendency to see it as separate from land, as apolitical, that it's land where sort of all the interesting politics happens. And where oceans have been considered, they've tended to be seen as, means of traversal, something that's kind of passed over, to kind of reach land masses and, thus explore where all the interesting politics happens. And that's a consequence really of a centuries-old historical bias, which separated nature from culture. And so, this sense then that the ocean is even interesting to look at politically is a very recent thing.
What's driven that, and what are sort of markers of that? I mean, is it as simple as technologies enabling exploration and exploitation, or are there other things going on as well?
I think there's a combination of different factors. We've got a change in the public consciousness. Obviously, there's something of a kind of blue planet effect where you have kind of increased media exposure around how oceans are important to the functioning of the Earth system and ultimately, of course, to humanity. You've got an increase in scholarship, which is bringing to fore, increased understanding. So we know what the issues are now better than we did before. But also, absolutely, there's a question for technology here. It's important to say that the deep ocean, the deep seabed, has been, in technological terms, known about for a while. There's quite an interesting history around the military, having quite an advanced sense of some of the things that deep ocean environments look like. But certainly in recent times, you've got the emergence of technology from a science perspective, but also, a very much an increase in that kind of profit driving maxim. You've got questions of what progress looks like. And of course, it's historically been framed in terms of economic progress, most recently sustainable development. So now we've got this, sort of emergent narrative of the blue economy, which has been around for, at least a decade now, which is basically looking to find ways of making money out of the ocean, albeit with a nod towards sort of its sustainable use, although you could be critical of that. So there's a whole series of different forces coming together. And I think what's interesting, particularly about deep sea environments, is that we've only gone so far with it. I think when we think about the ocean, we're still talking about kind of the place where all the interesting fauna's sort of swimming around and doing stuff that we can see, even something like blue planet effect, where you have an increased consciousness in public terms of some of the questions. It's still focused on pretty fish swimming around. They're less interested in what bacteria are doing, 5 kilometers under the ocean and why that should matter, for example. So
on this particular question of resource extraction and mining, obviously there's one set of questions, which is it feasible to extract resources from the deep sea? But then, as you said, it's whether it's profitable or not. Are there examples now of deep sea mining actually going on in practice?
Yes. So what you've got is there's around 30 exploration contracts. There is exactly 30. I think the last time I checked, exploration contracts given out by the major regulator, the International Seabed Authority, for mineral exploration of deep seabed in the area. So that's areas outside of the exclusive economic zones of countries, and that makes up over half of the world's oceans in aerial terms. So, there's about 30 different state-backed entities that are actively looking for minerals in those kinds of areas. Alongside that, you've got private companies that are also looking to extract in different places, and some of those are in the exclusive economic zones of individual countries. And where that's the case, then you've got new actors. You've got this negotiation happening between an individual nation state and a corporation. Now, for those companies, there's the one that I've studied over a few years in some detail was the world's first kind of commercial license given out for extraction, which was in Papua New Guinea. But the thing never took off. The company went bust after, best part of a decade trying to get going. And that was down to a number of things. Basically, investors got cold feet, put off by some of the environmental consequences which were being thrown around. But there was also a cost question there. Could it be profitable? And, there was a lot of pressure from civil society on that project as well, in terms of some of the human dimensions of extraction, which weren't picked up at the time.
What were the particular resources that contract was going after? And what, if you look across the 30 that we know about, that you say are in international waters, what's the sort of promise of these exploration efforts?
Yeah, it's a very good question, because, the sorts of metals, minerals, elements that are being looked for massively changed. They've all got their own politics associated with them. So in Papua New Guinea, it was gold and copper. So, you're talking there about, more or less conventional metals, things that we've mined on land, for a long time now. One of the kind of the major arguments that Nautilus Minerals, the company that wanted to mine in Papua New Guinea, made was that, you're saying you want all of these electric cars, for example, in a kind of a green future. Where are you going to get the copper from to build them? So you need new sources. So that was one of the arguments they made there. When you look at international waters, though, it's different. You get different deposit types often. So polymetallic sulfides, one of the big ones, but there's others as well. And yes, there is still those kind of conventional metals being searched for, but there's also quite a rise in looking for rare earth elements. So things like tellurium, for example, has been kind of talked up. That's an important component of photovoltaics. There's active searching going on for that. But other rare earth elements as well, all of which seem to be crucial for an expanding green energy infrastructure.
And is there any kind of settled view on what the kind of environmental damage of deep sea mineral extraction is? Is it very kind of context dependent on the particular place that these minerals exist or the particular methods for extracting them? Or is there starting to evolve a kind of set of concerns that are generally thought of when weighing up the benefits and problems of deep sea mining?
It does change depending on lots of different factors. Depth is a big one. I mean, there's differences in how you even define deep sea mining, for example. When does the deep start? So some people would say that, trawling the seabed, even at 200 meters depth sort of thing could be considered it. Some people have a problem with that. So things like phosphate mining, for example, underwater phosphate mining can be seen as, example, that has its own issues. But you compare that to something at 5, 6, 7 kilometers depth, and it's slightly different. I mean, I guess the key kind of environmental consequences people are worried about is obviously the disturbance of the habitats of benthic organisms. So, you're obviously digging up seabed. That's going to disturb, necessarily, all mining does disturb those habitats. Sediment plumes that are created through mining is a really big one. I think a lot of people kind of very concerned about that and how they, again, interfere with the behaviour and ultimately health of benthic ecosystems. And then sound pollution's another one. But all of these questions do change depending on the depth you're working at, because the technology used to get minerals from very deep on the seabed up to the surface and then across the land, it changes. And I think it's important when we think about deep sea mining, a lot of the consequences often we tend to think of like the deep seabed itself, what's happening on the deep seabed at the point of extraction. But if one thing should be made clear, resource extraction is never just about the politics of it. It's never just about the point at which the metal or mineral comes out the ground. There's a huge, long supply chain which is pumping that through, a huge water column. You're taking across vast amounts of oceanic space on a boat, where it's processed potentially on land with its own particular regulations and environmental questions. So, yeah, I mean, it's a huge, long area that metal and mineral is travelling.
Interesting. You mentioned about the Nautilus case in Papua New Guinea, that it was sort of some of the human questions that came to the fore that perhaps weren't anticipated by the main players at the time. What sort of human questions were you talking about?
Yeah, I mean, well, there's some obvious ones. So, things in terms of concern by communities that deep sea mining was going to affect their livelihoods, especially around fishing, things like that, which I kind of anticipated. I mean, I spent, 2 or 3 years out there on and off, sort of speaking to people, and actually the biggest, and I did lots of different things. One of them was a problem ranking kind of exercise. What do you consider to be the biggest threat, essentially, thrown out by deep sea mining? And the number one thing that came out wasn't really actually anything to do with livelihoods in an economic sense. It was to do with the disturbance of their spiritual belief system and their cosmology. So in particular, they have these particular communities have belief in so-called Masalai, which are kind of spiritual beings which live at the bottom of the ocean, basically, but they don't just stay there. They kind of move throughout their cosmology, and they were massively concerned. It came out the top rating on every single kind of way of measuring it, that disturbing these spirits, these Masalai, wasn't just bad news for how they think about the planet, but it was bad news because there would be consequences. That these spirits basically would get really angry. And, one of the consequences for this, I mean, just in sort of slightly philosophical terms, is that for them, there's this sense that spirit or that belief kind of is transported in the metal or mineral that is being dug up. So then when they look at a picture of a wind turbine, in that wind turbine is basically some of their kind of belief system. So it's kind of a cutting through really of the fabric of what they believe. So it's pretty foundational. And it's not, to be honest, it's not a sort of a very specific, although it is a specific example, it's not something which we should just leave there, because deep sea mining is happening or is being targeted in different parts of the world. So South Taranaki in New Zealand, you've seen Maoris getting, having a really sort of prominent say against it. again, questions of customary land rights there coming to the fore. And so when you look in sort of all of these kind of communities, they're important questions. They're just unavoidable.
I mean, it also has echoes of the controversy over the Brent Spar, the decommissioning of Brent Spar in the 1990s in the North Sea.
But yeah, I mean, I think there is just a broader point there again that, when we think about the deep ocean, especially something is in an extreme environment like that, it's very tempting to think it as a place which doesn't have human consequences directly, but of course it does.
My understanding of the Brent Spar controversy was that there was a sort of environmental risk assessment done that said it would the least damage environmentally would be done by disposing of this oil storage in the relatively deep sea, but that was not, but the public controversy that raised was about the idea of, is it right to pollute what people think of as a sort of pristine, undisturbed environment?
Again, with kind of environmental impact assessments and similar kind of mechanisms, I mean, you've always got questions of power. There's always questions of what is said, what isn't said, who is included in that decision-making process, et cetera, et cetera. So, these aren't sort of objective statements of how it is. And there's echoes in the world of the deep sea again. I mean, there's a whole, it's a slightly different thing, but there's deep sea tailings disposal, which is, again, basically landed tailings. So the consequences of land mining, terrestrial mining, being pumped into the deep ocean, because, again, it's sort of seen as out of sight, out of mind. And, that's an extremely controversial practice as well.
Final sort of question, thinking particularly about the international waters and the, you talked about these 30 kind of licenses. Is it license? I mean, what is the kind of authority by which this international body grants permission for these 30 kind of mineral extraction explorations studies?
Yeah, so they're called exploration contracts, and they're issued by an organisation called the International Seabed Authority, which is an arm, basically. It's a regulatory function of UNCLOS, the United Nations Convention on the Law of the Sea. So it's created quite a time ago, and they're basically there to, regulate basically who does and who doesn't use that area, as it's called, and how is it used. So there's guiding principles. We have the guiding principle of the common heritage of mankind, for example, for that. But right there's loads of interesting questions. It's supposed to be about kind of holding in trust for future generations this kind of cultural and natural heritage. But at the same time, there's a lot of assumptions in that. Okay, so there's a feminist critique of that. For a start, the mankind. There's a human bias towards that. So if you call it humankind, then you're writing out, spirits, for example, as I mentioned earlier. But you're writing out kind of agency for animal life, for example, bacteria. For all these different interesting political actors in their own right. And you're not doing anything to engage with the fact that, as we know, humankind has been very much an uneven object of analysis. I mean, just look at the history of oceans in your sort of black geographies, for example, being completely different to, say, Eurocentric or kind of US-centric histories of the ocean. Slavery being a very obvious example of how the ocean is politically just different. So something like the mankind's designation doesn't capture that enormous diversity, and there's questions there about who should benefit from the deep sea mining, for example. Who should benefit from that, let alone who should bear the costs of that. Given the fact that we've had this very uneven distribution of benefits and costs historically. Yeah.
What do you think is likely to emerge as the sort of some of the most pressing issues that are considered when thinking about exploitation of the deep sea in these international waters? Do you think that, I mean, you've talked about the critiques of the current regime, but obviously the current regime does offer some sort of, if you like, oversight or protection. How do you anticipate these debates evolving over the next decade or so?
Well, I mean, right now the International Seabed Authority is drawing up exploitation codes, basically. So, everything's pointing towards a shift away from exploration to exploitation. That's why there's so much kind of pushback, I guess, from critical communities, because, that's obviously a scary thing. It's not like terrestrial mining where the horse is already bolted, essentially. There's an opportunity here to kind of know more about the kind of environments that we're engaging with before, these kinds of big decisions are taken. If exploitation starts to happen on an industrial scale and we get more of it, there's loads of questions, and there is important questions about the trade-offs required for an expanding green energy infrastructure, for example. If you want more wind turbines, if you want more photovoltaic panels, if you want more electric cars, where are you going to get the metals, minerals from? And so there's a compelling argument on the one hand that the deep sea can provide some of that, but then there's also hugely compelling questions that go against that about what does a fair, just way of doing that look like? How should it be regulated? Should it be in the hands of an authority set up in a particular way at a particular time? And also, as I said earlier, and I'll keep coming back to, how do we try and factor in a range of belief systems which don't necessarily map onto this dominant one, which we've seen historically.
Thank you, John. That was great. Now, Kevin, thinking about Antarctica, what's the kind of current state of the environment in Antarctica? How do we think about the state of the environment? Is it in a sort of pristine state? Is it being impacted by humans in various ways?
So it really depends on where you are. Antarctica has an area of 14 million kilometers squared, and 99.7% of that is snow and ice. And only that 0.3% is ice-free. And actually, the ice-free ground that's near the coast is where you find the great majority of the Antarctic research stations because of ease of access, etc. And it's those locations that have been predominantly impacted by human activities over the last, since the middle of the 20th century when research stations started to be established. Unhelpfully, that strip of land that's near the coast, which is only about 6,000 kilometers squared in area, that's about half the size of Yorkshire, that contains the vast majority of the plant life, penguin colonies, the seal hole-out sites, the nesting sites of various bird species. And that inevitably leads to some sort of conflict and impact between both sort of the human activity in the region and the native species. So that is problematic. In the marine environment, we have seen exploitation of firstly the seals back 200 years ago when sealing started in Antarctica, but also whales have been severely impacted by whaling over the years. They've taken out finfish, and now we're looking at extracting krill in large quantities. So there's a history of exploitation within that area, and the continent has changed as a result of that.
Could you say something about how it's changed?
So when we look at sort of the impacts that we're seeing, you can kind of divide those into two types. There's the impacts that have been caused by human activity on a global scale, and that would include climate change. We've seen collapse of ice shelves, we've seen receding in glaciers, predominantly in the Antarctic Peninsula region. And also we've got organic pollutants brought in by atmospheric circulation. We're seeing plastics being brought into the region through ocean currents. So these are all things that are happening outside Antarctica. But then whenever you go into Antarctica itself, we're seeing impacts caused both by the national operators, which have their research stations and do their science down there, but also by the tourism industry, which is expanding and how it has expanded quite dramatically in the last 2 or 3 decades. And on top of that, you've got the fishing industry, which does cause release of sort of plastic waste and other such things into the ocean. But what the sort of impacts that we're seeing would include the introduction of non-native species, potential introduction of pathogens, which have impacts on the native wildlife, trampling of vegetation by visitors, etc., and disturbance of the wildlife that are already there, and also even the displacement of some of those species through the construction of research stations, etc. And on top of that, you've got general pollution caused by emissions from combustion of fossil fuels, release of sewage into the marine environment often, and that's probably about it. But so there's lots of various things that can go on, and we need to kind of try and minimize those impacts as much as we possibly can.
I mean, regardless of whether these are pressures coming from as a global activity or more local activity, how fragile is are the ecosystems in Antarctica? Do we know if they're sort of resilient to these sort of changes, or are there particular reasons why we should be concerned about the state of biodiversity and the environment?
Antarctic environments are, by their very nature, quite a bit more fragile than some of the ecosystems and habitats you find in other parts of the world. So if you're at some of the more remote nunataks, for example, the sum of the biology might be a few microorganisms, a few species of fungi and bacteria. So it only takes a researcher with some mud on their boot to turn up and for that mud to get scraped off. And you've completely changed that community forever. And there's no going back, So at that level, it's a very fragile system. But ultimately, I don't think we really understand the impacts, for example, of pollution on some of the species that we're having down there, because they are not used to this sort of thing. They're already highly stressed from living in such an extreme environment, and that little bit more stress to do with pollutants or whatever might be enough to cause them to become, to die or become extinct locally.
Therein is the dilemma, isn't it? Because the very action of the scientists to understand the environment can be damaging to the environment. And so, is there a choice of not knowing how fragile it is and leaving it alone, or understanding how fragile it is and damaging it in the process? How do you as a scientist think about those tensions?
Yes. And that is a very, very good point. If you think about it, to actually go to Antarctica and do research there, it's hugely difficult and creates a huge amount of carbon dioxide emissions. So even the act of doing any science at all leads to CO2 emissions. It also leads to impacts on the ground. I think we need to be sensitive to the fact that Antarctica is a continent that has actually been devoted to science and the freedom of scientific investigation. So that in many respects, that's the very reason that we're there in the first place. That's the driver for a lot of the activities and the governance of that region. So in reality, it's not going to stop. But I think we can start to think about how we undertake that work, where we undertake that work, and how we perhaps set aside sites that are pristine, that are for the future, that we can be confident they are as pristine as they possibly can be.
And so that brings us to this question of the governance, the regulation of Antarctica. So how are decisions made about where to set up scientific stations? I mean, tell me, what is the status of Antarctica?
So everything south of latitude 60 degrees south falls within what's called the Antarctic Treaty area. So the Antarctic Treaty was signed back in 1959 and entered into force in 1961, so 60 years ago. And this was actually a nuclear treaty that basically set aside Antarctica and excluded it from any nuclear weapons testing or the dumping of nuclear waste. But it also set aside Antarctica as a continent for science, and it guaranteed freedom of scientific investigation there. And it also set aside some of the territorial claims that were causing tension in the region at the time. So that's kind of the overarching international agreement for the region. When it comes to environmental issues, we have the Protocol on Environmental Protection to the Antarctic Treaty. So it was signed in 1991 and entered into force in 1998. And it's the document that famously prohibits mineral resource activities in the area, and also says that any activity must be undertaken after an environmental impact assessment has been performed, to really minimize the impacts and understand potentially the impacts of all activities that are going on in there. It also sets aside Antarctica as a continent for peace and for science. So, it's quite comprehensive in the extent of the coverage of the issues that it looks at.
So we've talked about activity local to Antarctica that is and may cause environmental damage, such as tourism, fishing, and scientific research. Those are the three main activities. Is that right?
Yep, that's correct.
So if I want to visit Antarctica as a tourist, how is that then decided whether that trip, should go ahead or not?
So these international agreements on their own have no standing, and it's only whenever they're introduced into a nation's domestic legislation do they actually have any force. So in the UK, we've got the Antarctic Act of 1994 and 2013, and that's what you would be prosecuted under if you were to do something unhelpful in Antarctica. So that's the way it works. So we, within the British Antarctic Survey, undertake environmental impact assessments for all activities that we do. And we run everything through the UK government, through the Foreign, Commonwealth and Development Office. And they're the ones that say, yes, that's fine, off you go. And if you need any permits for any particular activities, they're the people we go to. So that's the system that we have, but it very much depends on which nation you're going to Antarctica sort of under. So for example, I've got bit of an accent. I've got dual Irish UK citizenship. If I was to go to Antarctica as an Irish citizen, they haven't signed the Antarctic Treaty. There's nothing in Irish legislation talks about Antarctica. I guess in theory, I could go down there, start extracting minerals, or I don't know, harvesting penguins for penguin soup or something like that. And I'm not very sure how on earth I would actually be prosecuted for that, because there's no legal system for that to occur.
Well, that's very interesting because, in our first episode, we talked about changing technologies, which mean that spaces such as Antarctica, the deep sea and space are becoming more accessible. So does that mean there's more demand to visit and exploit Antarctica, and particularly then brushing up against the kind of problems that you're talking about, that not all countries have legislation that covers Antarctica?
So I think you need to kind of remember that within the Antarctic Treaty itself, it says if you want to participate in the governance of the region, you need to demonstrate substantial research activity there. And most Antarctic Treaty parties have interpreted that as the construction of a research station and the development of a scientific program. So that inevitably leads to environmental impact down there. So there is a tension that's almost been developed by the system itself in terms of active participation in the governance versus the fact that you're going to have some sort of impact by taking up that role. So it is quite difficult.
What kind of questions would you like to see emerge in a kind of more public debate about how humans interact with Antarctica? What do you imagine would be productive kind of conversations that you'd like to see happen?
If you think about it, in Antarctica, a lot of the activities that have gone on under there have occurred at a national level. So you have a US station or a Russian station or a Chinese station. Although there is a lot of scientific cooperation, each nation makes a point of saying this is our bit and this is the bit we're working from. This is our station. We don't have that same level of international cooperation in terms of infrastructure that perhaps we have in space, the International Space Station, for example. And I think if we can develop a more integrated approach in the future, we can reduce the human impact. There's plenty of research stations which have spare beds where we could be putting scientists, but because each nation acts independently mostly, that resource is not being fully exploited.
Thank you very much, Kevin. Now, turning to you, Nikita, perhaps we could begin by talking about space debris, which is a growing concern. Why is it that space debris represents a challenge that needs to be thought about?
The first thing is that we need to recognize that a lot of our socio-economic activities actually relied on the satellite infrastructure that we currently have. So even though we can't see how satellite functions in tandem without a satellite, it is actually critical to our daily lives. And I think up until recently, there is this sense that we kind of take the smooth functioning of the space infrastructure for granted. We're now coming to a stage where we see the increasing commercializations of the space sector. So more private actors are coming into play. And with the new trend of introducing mega satellite constellations, meaning that instead of just putting one or two satellites up in orbit, we are going to build constellations in the thousands to work together.
So much of daily life today depends on the space infrastructure. So perhaps you could just spell out, just a few examples of how our lives are dependent on space as we currently use it.
For example, weather forecast and television broadcasting, and also satellite navigations in our mobile phone, a lot of the digital economy that use some sort of geolocating functions, like satellite navigation contribute partly to that. And also because satellites need to communicate to Earth, it relies on radio frequency transmission. It means that if there are more satellites in orbit, it would actually put a lot of pressure on the spectrum. And a lot of different technologies also use that spectrum, including our phones and also new technology such as mega satellite constellations. So we're all sharing the same radio frequency spectrum. So it is linked to the space infrastructure. And last but not least, we know that data derived from space has helped us to do climate change modeling. So it means that actually space also play a part in the global effort in combating climate change and also to ensure sustainability.
And then you were talking about quite a rapid shift to deploying these mega constellation of satellites. What is that going to make possible?
I think one of the major factors is that we're seeing more private actors becoming active in the space sector. So whereas in the past, during the Cold War, we see mainly governmental entities responsible for launching of satellites. And now increasingly we see the commercialization aspect, which drives innovation in technologies. So that comes with pros and cons. So in a time when we are turning towards the introduction of mega satellite constellations and using kind of off-the-shelf ready components, it does kind of drive the cost of building satellite down, which is good because we can derive a lot of economic benefits from cheaper satellites. But at the same time, the cost become less inhibitive to launch satellites into orbit, we need to kind of also make sure that whatever we launch would be tracked and followed and deorbit, in a sustainable manner. That whatever space activities and expansion in the space economy that we are pursuing in this generation does not negatively affect our future generations in using the space infrastructure.
So within that context, what are the risks that are posed by an increasing amount of space debris?
So space debris would be one area of concerns. Another area of concerns would also be frequency interference if we have more satellites up. In different orbit, there may be different main concerns. So in the low Earth orbit, which is the orbit closest to Earth, we may be more concerned about collisions if we have really an explosion of number of satellites in that orbit. If we have collisions, then it could pose challenges to other functioning operational satellites because it is not a car that we can stop. We have to remember that in space, there is no frictions because it will just keep on going. So if you have a collision, whatever debris that was kind of propelled out from that kind of collision, we just keep on continue orbiting Earth in a very high speed, possibly, unless it was stopped by other object. Currently, we don't have an economically accessible way of removing space debris. So we want to make sure that the probability of collision with space debris or between functioning satellites are kept to a minimum because there's just very little that we can do if things go on in space. And also, even if we do have maturing technology to actually go to space to solve some of the problem, at the moment, we're still looking at astronomical prices. So it's not like we know that there is a lot of pollution in the ocean and that needs a lot of resources and human effort to maybe remove. But essentially, this is still something that if we put enough resource into it, we could, address it as much as we could. Whereas when there are accidents or catastrophic incidents in space, at the moment, there is very little we can do. Before we put ourselves in that kind of vulnerable positions, we want to make sure that whatever we launch in space is well coordinated. We have thought about the risk, and we have put in place a mitigation measure to prevent catastrophic event.
So before we sort of talk about the mitigation measures and the governance, could you just give us a sense of what the current levels of space debris are? Is it something that currently is impacting on the operation of satellites in orbit, or is it really more a prospective issue, a problem for down the road?
One of the major challenges to communicate the threat of space debris collisions or increasingly crowded orbital environment is that it's very hard for us to verify the direct cause of malfunctioning that could be attributed to space debris collision. Like I said, because there is very little that we can do when incidents happen. So it also means that we also have very limited means to ascertain that is due to space debris or not due to space debris. But I think if you look at the International Space Station or in the past, the space shuttle returning from space, there is a lot of kind of dent on the space shuttle. That's because it collided with small debris. So luckily, so far, we have no catastrophic event that's directly verifiably attributed to space debris collision, but it doesn't mean that is not an issue that is of concern. So at the moment, major monitoring networks on space debris tracked around just under 30,000 space objects. But according to estimations, there are around at least over 30,000 space objects greater than 10 cm. And in the range of smaller space debris, let's say from 1 cm to 10 cm, we currently estimate the number to be at 900,000. And if it's smaller than that, 1 millimeters to 1 centimeters, we're talking about million space debris. So all this debris could travel in very high speed. I think so far we count ourselves lucky, but it is as with most threats, same with plastic in the ocean or climate change. In the beginning, we can't directly feel the impact, but usually when we start to feel the impact, it will be too late for action.
Nikita, I mean, just to give me as somebody with no real knowledge of space a sense, is 30,000 objects 10 centimeters or larger a big or small number? I mean, space seems huge. And I've got no sense whether 30,000 is a tiny number or a medium-sized number or a big number. How do we kind of assess the significance of that number and the sort of threat it represents?
So in comparison, we can look into number of functioning satellites that we have. I think the latest number is that we have just under 4,000 satellites functioning. So that is a huge number. And we are just talking about objects that are larger than 10 centimeters. If we are trying to estimate the number of space debris from 1 mm to 1 cm, we're talking about millions.
Yeah.
So if we have only less than just under 4,000 functioning satellites, and we have millions of debris, if it's very small, I think that number is going to tell you that space debris is not a question of if, it is a question of when.
So just to recap, in terms of how we deal with it, how we mitigate this risk, you're saying that there's basically two ways of doing it. One is to have technological capability to remove debris, and you say that is becoming possible but is likely to remain very expensive. And the second is just to work hard to avoid collisions that create the debris in the first place. Is that summarizing your position correctly?
Yeah, I think one of the most important thing we can look into from a policy perspective is to make sure that the international community is talking with each other and coming to a shared understanding that we need to have responsible deorbit behavior. So we need to have hopefully binding, but if not, at least some form of understanding that satellite coming to the end of its life has to be moved to orbit, moved to a graveyard orbit or deorbit, so then it will be destroyed upon entering the atmosphere. It is a little bit difficult given the current geopolitical tensions for multilateral efforts to become binding. I think it's very hard on all topics. Second of all, on the technology front, we already have increasing interest in space debris removal technology that is getting good investment. But like I said, it's going to still take some time before it can become commercially accessible.
Nikita, we have the sort of exciting news that there's the launch of the UK-Japanese test to try out a technology for removing space debris.
Yes, I think that's very promising, and it's great in comparison to maybe 5-10 years earlier, where this kind of technology does not attract as much attention as now. But we need to keep in mind that I think the current development of debris removal technology focus on debris that we can track that is larger than a certain size. So if we're talking about space debris, like very minor paint measuring like millimeters, then I don't think those kind of technology can remove it. And because those really small space debris can, if travel in a very high speed, can still cause impact and still cause problems. So I think space debris removal technology can address one aspect of issue, but not completely remove the difficulties about increasingly crowded orbit. So that comes to the second type of technology that is, for whatever reason, not as hyped at the moment, which is on-orbit surfacing technology, which means that we try to introduce technology that allow future satellites to become repairable, refuelable, because currently the majority of satellites cannot be repaired nor refueled. So depends on which orbit you send a satellite to. Their satellite would have a lifetime of maybe 10, 15, if not put it to a stretch, 20 years, and then it will become basically space debris because it doesn't function anymore because it cannot be refueled, it cannot be recharged, it cannot be repaired. So we can also kind of start to look into changing the business model by looking into technology that allow future satellites to become more sustainable.
I mean, that's fascinating because, yes, you've really sort of helped understand both the nature of the problem now, the kind of the potential dramatic increase of the problem, and then some of the solutions, which are, perhaps to remove debris that's there, to think about responsible deorbiting or decommissioning into what you call the graveyard orbit or deorbiting. But then most interestingly, perhaps the idea that, making more sustainable the life of satellites through this sort of refueling and repair and perhaps, multi-functioning over time. So just my last question is really about the governance. So you're saying that this will require greater cooperation, greater collaboration between countries and between companies. What's the kind of governance mechanism that you think will have to operate to achieve the kinds of results you want to see?
I think the most effective way to address this issue is to actually conceptualize space resource or space debris as a sustainability issue rather than a space issue. Because essentially it is about sharing of common resources. It's just like the ocean. It's just like the climate. It's just like the air, that these are all resources that we are sharing. And if we don't coordinate or if we don't think about future generation when we use these resources, even though we can't really touch it or feel it, we have problems, further down in line. So I think instead of talking about space as an isolated problem, we need to start to understand that it is about a resource sharing issues. It's about sharing global common resources. And I do understand that there may be some reluctance in conceptualizing kind of, orbital slots or radio frequency as global commons. But I think the most effective way is that we need to recognize that space technology help address climate change. So we need to kind of address the climate change and space debris problem in tandem rather than thinking that this is something that we can prioritize, because all this topic interplay with each other.
I just want to say that's hugely helpful. And thank you very much, John, Kevin, and Nikita, for joining us for this discussion. And thank you for listening. Join us next week as we celebrate our podcast's first birthday and join the discussion about how research in space, the deep oceans, and in Antarctica is shedding light on climate change. CSaP's Science and Policy podcast is a production of the Centre for Science and Policy at the University of Cambridge. The series is hosted by me, Rob Doubleday, and is produced by the fabulous Kate McNeil, with the excellent support of two PhD interns, Alice Millington and Anthony Lindley. You can learn more about CSaP's work by visiting us on Twitter at CSciPol or visiting our website www.csap.cam.ac.uk. If you have any feedback about this episode or ideas for issues we could explore in future episodes, please email us at inquiries@csap.cam.ac.uk. Thanks for listening.